So we're going to spend another day on law of sines. And you might wonder, why? Law of sines is so easy. Um, well, there's something called the ambiguous case, which means there's a situation where sometimes we have two solutions and we have to know how to handle that. So depending on what you're given with the triangle, if you're given two angles and one side, then you're going to have one unique solution. Remember, if you know two angles, then you really know three, because the other angle, you just add them up and subtract from 180. If you're given two sides and you're given the angle opposite one of the sides, then you actually have three possibilities. Maybe there's no solution. Maybe there's one solution. Maybe there's two solutions. Now, this is the case that will be the trickiest. I'm going to show you that when there's no solution, it's not a big deal, because when you try and evaluate the problem, you'll get your answer you'll get an answer that will say basically no solution. It will give you an error on your calculator. When you have one solution, you'll get the solution. It's when you have two solutions that you have to do a little bit of work to figure it out. Now, if we were having class, I would actually give you a handout of this because if we were physically in class, because this is important. It's not in your textbook. This is a little flow chart that's going to help us decide how many solutions there are. Now, like I said, the only issue is when there's two solutions. So really, it's just this top row that you would for sure need to have. So if you want, or what you might do is make a, just pause this and make a copy of this. I don't mind attaching it as a document, a separate document as well, so that you could just pull it up and look at it when you're doing your homework. That's fine. But I'm going to show you how to go through this and how to use this. So here's our first example. And we have triangle ABC, and typically I'll draw it like this, A, B, C, and I'm labeling it. So when you draw these triangles, side A is opposite angle A, side B is opposite angle B, side C is opposite angle C. So that is, kind of understood how we're setting this up. So I set it up. Now you'll notice that I have my little fancy tools here, because I actually drew this out using these. Just so that you guys would see it's, you measure the bottom numbers here, 45 degrees. So we've got that matches. Okay. So as we go through now and set this problem up, now I'm going to pull up, let me see how I'm going to do this here. Hold on. Okay. So case 1, angle A is less than 90 degrees. Yep. So now we have two options. A is less than B. Nope, because A is greater than B. So we are actually on this one, and now this tells me there's one solution. So as soon as you know there's just one solution, you just find it using the law of sines. So sine 45 degrees over A, so sine A over A, remember, equals sine B over this side 12. So that's what I'm going to do. Then I'm going to set this up and solve for sine B. So I have 14 sine B equals 12 sine 45. By the way, sine 45 degrees, we know this is the square root of 2 over 2. But I'm going to go ahead and just use my calculator to go through and do this, because sine B, I don't know that that's that's going to be a special angle. So grabbing our calculator, so we've got sine B equals 12 sine 45 over 14. So I'm going to take 12 sine 45, divide by 14, and remember that's sine B, so I have to do inverse sine of that. So I'm going to go inverse sine recall that. To recall it, you go second and then answer, so this the negative sign. So we get about 37.3 degrees. Now, I would, you could store this. Let's not worry about the rounding issue. I know we're going to end up rounding more than once, but that's okay. So I'm going to label this 37.3 degrees. So now that I know this part of it, because I'm trying to solve the triangle, I need to find all the missing parts. So now I know if I take 37.3 plus 45, and we want to do 180 minus that, and I get 97.7 degrees for this one. And now I need to find side C. So I'm going to have, I'm still going to use sine 45 over 14 equals sine 97.7 over C. Now the reason why I don't use B is because this was rounded, so at least that gives me a little bit more accuracy. So then side C, I'm just going to do this. We got 14 times sine 97.7, close parenthesis, divide by sine 45, and I get about 19.6. And now my triangle is solved, and there's only that one solution. So I have all the angles and all the sides. Okay, so here you can see we have another problem. So angle A is 35 degrees, and I'm not going to get my protractor out and show you that. I'm sure you believe me. And side B is 14 and side A is 6. And I think I have this in the way so you can't really see it. So let me move this out of the way. Oh, I guess I didn't label that. So we have a 14 over here. Now, let's look at the little chart and see how this would play out. So angle A is less than 90, so I want this chart. The other part I'm not showing you is from here where angle A is greater than 90, so that we haven't seen one of those yet. So here, angle A is less than 90, and notice that A is less than B, and it is. A is less than B. Okay, so we are on the top part, so we're up here. So now notice what we have to check. You see these different conditions. A is less than B sine A equals B sine A, or A is greater than B sine A. So notice that we need to find B sine A. So we're going to find B sine A. So on your calculator, so if we do 14 times sine of 35, I get 8.03. And so now I have to compare that to A. Well, see, 6 is less than 8.03. So A is less than B sine A. So I'm here, and it says no solution. Okay, so we know the answer is no solution, which of course you knew because, look, I couldn't draw it. This was, I had gotten my ruler out, and it didn't work to draw those measurements. So let's suppose you don't take the time to go through all that, and you just look at the problem and you say, well, I'm not even going to worry about that. I'm just going to solve sine A over side A equals sine B over side B. And I'm going to solve this. So I get 14 sine 35 divided by 6. And I'm going to do inverse sine of my answer. Oops, it says I have an error. That's going to clue you in, oh, this was one of those no solution problems. Let me just point something out to you though, that's important. 14 sine 35 divided by 6. We get this, which means that sine B is about 1.34. Do you remember when we talked about the value of sine because it's opposite over hypotenuse and it's a ratio of sides and it's always less than 1? So that's why you end up with a domain error. There's no solution. So that's why I said the no solution ones, no big deal as long as you know what to do with the error message that you get on your calculator. So here's example 3. And we're told that angle A is 42 degrees. Side A is 13, which is my one over here. I don't have it labeled, well, I can label it there, I guess. So we get a 13. And side B is 16. And I got my ruler out and I measured it and everything was good. So let me show you how you determine the number of solutions on this. Okay, so we've got angle A is less than 90 degrees. Okay, so we're in this part. We have side A is less than side B, which puts me on this part. So this is when I need to know what B sine A is. So I'm going to take the time to figure out B sine A. So we have 16 times sine 42, and I get 10.7 approximately, and I compare that to A. Well, A is 13, so 13 is greater. So notice that puts me at 2 solutions. So that's how you test for it. So now that we know that, to find the first solution, do just like what you know how to do. So I'm just going to work with this triangle right here. I'm going to do my work kind of in the middle of it. So we have sine 42 over 13 equals sine B over 16. So make sure you see how I'm doing that. And now I'm going to solve. I'm going to get sine B equals, so we're going to do 16 sine 42 divide by 13, and I get 0.82 approximately, but I want to know B, so I'm going to do inverse sine of my answer, and I get that angle B is about 55.4 degrees. So that's here, 55.4 degrees. Well, now I can figure out angle C. So 55.4 plus 42, and we do 180 minus that, and I get 82.6 degrees. So now we're only missing one part, and that's side C. So I'm going to use the part that I knew for sure. So sine 42 over 13 equals sine 82.6 over C. And now we're going to do that. So we get 13 times sine 82.6 divide by sine 42, and I get 19.3 approximately. Now, I want to point out too, notice that the smallest side is opposite the smallest angle, and the largest side is opposite the largest angle. So remember, that's a property with triangles that you need to remember. That can come in handy. So there's one of my solutions. So now the big question is, how do I get the other solution? So notice this line that I have drawn in blue. And if you were to take this piece right here, and if I were to rotate it, you would see this is the same length. So this is also 13. I could get the ruler out and show you, but I'm not going to. So now we just know that the 13 is opposite this angle right here. But perhaps it's not an acute triangle. Perhaps this side goes here instead. Notice that this side in blue is also 13. And notice that this angle is still 42. So we don't know for sure if the side is here or if the side is here, because I still have an angle of 42. Side A is still 13 and side B is still 16. Now my angle B is going to be different, but it could be that triangle. So we're going to do this problem now, and I'm going to kind of separate this out onto another page so that we don't get all the other stuff in the mix of that. Okay, so I got rid of some of that work, although I'm still going to leave my original angle B 55.4 degrees because that's going to be important to help me find my other triangle. Now we want to focus on this triangle over here. So this is going to be my new angle B. So I'm going to use a different color. You can use a different symbol if you want. You could even call this like B prime and put a little mark right here, just so you know it's different from this angle B. And I need to figure out what this angle is right here because that's my angle B for my second solution. Well, notice that this other triangle that I left here, it has a 13 on this side and a 13 on this side, which makes this an isosceles triangle. And if this piece right here is 55.4 degrees, then this piece is also 55.4 degrees. So if I want to figure out this angle that I've called B prime, to figure out what B prime is, I'm going to take 180 minus this 55.4. So this is my starting point. This, for my second solution, this is the first thing I have to do. I have to use the angle that I found in my first solution and subtract it from 180 to figure out my obtuse angle to do that part of it. So when I do that, I get 124.6 degrees. So that is this angle in here. Okay, so now I know that. Well, if I know that that is angle B and I know angle A, notice that I also have a new angle C. I'm going to call that C prime. So to figure that one out, I'm going to have to add 124 plus 124.6 plus 42 and subtract that from 180. Okay, so we have 42 plus 124.6, and we're going to have 180 minus that. So I get 13.4 degrees. Make sure you use degree. A small case C looks like looks like an uppercase C. So make sure when it's the angle that you use the degree, and if I don't see a degree symbol, I'm going to assume you're talking about the side length. So now I know that piece. So what's left? I'm missing side C, but I have to use it with my new angle. So I'm going to take sine 42 over 13, that's sine A over A, equals sine 13.4 over side C. And I'm going to solve for that. So I get 13 sine 13.4 divided by sine 42. And I get that my new side C is about 4.5. So now I have solved the triangle, I have all the pieces, and I've solved both solutions. That obviously is the trickiest thing when you have that those two solutions. Now the other thing I want to point out to you is when you go through and talk about this A, B, and C, remember it's the relationship of those sides, not the names of the angles. So if you were given X, Y, Z instead of A, B, C, you'd have to make the proper adjustments if you were trying to use this formula or this chart to help you figure those out. So that takes you through, again, remember it's only the two solutions. So if you just blindly use the law of sines without paying attention to this chart at all, then the worst thing that will happen is you don't get your second solution if it had two solutions. If it was a no solution, you're going to get an error and you'll know it's no solution. If it's one solution, you'll get it. It's just if it's two solutions that would be an issue. One other thing I want to talk about is area of a triangle. And when you are doing area of a triangle, you guys know that it's the base times the height, 1/2 the base times the height is the area. So we know that. So I want to put that into perspective of this and show you how you can avoid having to know the height. Because a lot of times, if you just have triangle ABC, you might not know the height. So what could you do without having to find it first? So for this one that I drew, if I wanted to find the area, I would take the base, or 1/2, times the base times the height. So I don't want an H there. I want to put it in terms of, my A, B's, and C's. So I'm going to use angle B over here. And if I take sine B, now notice this is a right triangle, so I could do opposite over hypotenuse. I would get H over A, which means that H is equal to A sine B. So now what I'm going to do is I'm going to substitute that over here. So I get that the area is 1/2 times C times A sine B. And then I'm just going to put that in alphabetical order. So we get the side AC and then sine B. This is how you can actually find the area. If you only knew two sides in an angle, as long as your two sides, notice this is with side C and side A, and the angle is the angle that's in between them. This holds true if it was 1/2 AB sine C, or if it was 1/2 BC sine A. Notice that whatever two sides they are, it's the other angle. Okay, notice in each case. So it's not hard to memorize because it's 1/2 the product of the two sides times the sine of the angle in between. So this is how you can find the area. These do not have to be right triangles. So if you know, for any triangle, you can find the area without having to know what the height is. So that's kind of cool to know. So I have one problem here. Find the area of triangle ABC if angle A, so if we were to look at something like this, I'm just going to sketch out a triangle, kind of a generic triangle. I don't worry about the sides here. So A, B, C. So angle A is 36 degrees, C is 23, and B is 35, so obviously not drawn to scale. Notice I know two sides and the angle in between. So to find the area, I'm going to do 1/2 times the two sides. And notice I'm not even paying attention to what formula I'm using as far as the A's and the B's and the C's. It's just the two sides times the sine of the angle in between. And we don't have to go through and do that. You could plug that into your calculator at this point, and then it would be whatever you get, square units. And that way you don't actually have to find the height. So that takes care of the lesson for today. So I'll be posting an assignment tomorrow for you to work on these types of problems.